Ready? Are you sure? Are you sure? All right, class.
Yes.
All right, so I'm hoping everyone's going to be paying 100% attention all the time. No one's going to be playing with their phone right now, right? Looking at the TikTok, those Instagrams, or whatever. Is that Instagram? Even worse. Okay? It's not. It's TikTok. It's even. Anyway, for those people that are trying to get these notebook grade, this is page 37. So everyone write pound 37 on your paper right now, because you know what's going to happen? There's going to be some people in this class that are going to walk in here on Friday, ask me for my notebook and say, hey, where does this page go? Or what is this? Or even worse, they're going to go around to everyone else asking them for their table of contents or their page numbers. Or can I see your stuff? Because they're not going to do their stuff until the last minute. I'm going to say, oh, nope. Okay, you're turning it in that time right there. You don't have time. That was before. So, page 37. Probability of an event not occurring. Now, a complement. So, first thing I'm going to do. So, Melvin, you ready? What is the chances of Melvin passing this class?
100%. 70.
70. We got 70% over here. A 70% chance of Melvin passing this class. Now, the complement to that is, what is the chances Melvin not passing?
30%.
30%, right? So notice what the complement is, right? It adds up to 100%. It is the piece that is missing. So if passing is 70% for Melvin, not passing, the complement would be 30%. So it's 100% minus the 70%, which Melvin is going to be for passing, is going to give me a grand total of 30% as my not passing. That's what the complement means. This is my notation of what it's going to look like. So the probability of not event happening is equal to 1 minus the probability of it happening. Okay? In this case, it was 1 minus my 70%. If you are dealt a card, one card from a standard 52 card deck, find the probability that you are not dealt a queen. First, probability of a queen. How many queens are in that deck of cards? There's 4 queens. Out of how many cards? 52. So I'm going to leave it here like this. So there is a 4 out of 52 for this one. Now, the complement would be the not. So the probability of not queen is going to be 1 minus 4 over 52. I'm going to do a little bit of math. You can plug it straight into NumWorks. It'll do it for you. But I like actually doing it as common denominators. So that 1 is going to turn into 52 divided by 52. That's still 1, isn't it? Yeah. Minus 4 over 52. So do the math. I get 48 out of 52. Is that pretty easy there? Now, when we're doing our math and plugging into our answers, it's going to ask you several different ways of answering this. So, first way, so we said 48, 52. One of the things it's going to ask for, it's going to ask for the fraction. It says reduced or simplified fraction. So that answer, as I plug that in, is not going to be 48 out of 52. It's going to be 12 out of 13. Does my NumWorks calculator do it for me? Yes. Yes, it does. So that's going to make life easier. So it's 12 out of 13 as my fraction, my simplified fraction, or as a percent. What would that be as a percent? 92.3. Is that pretty easy there? ¿Está muy fácil? Sí, sí, muy, muy fácil. All right, anyone got questions before I go on too far? Too easy, right? Okay. Next one. Mutually exclusive events. Mutually exclusive events. Now, a mutually exclusive event is.
I got that wrong one.
So, this is mutually exclusive. Okay. Melvin. He's either passing or he's not passing. Can he be both? No, he can't be both. It's either you're passing or you're not passing. That is an example of a mutually exclusive event. Either you're this or you're this. One or the other. So, these are referred to as OR probabilities. If A and B are mutually exclusive, then probability of A happening will turn into, see this OR statement? This is going to be where a lot of people forget what they're doing, and then this is where it's going to become complicated. Probability of A plus probability of B. So if there's an OR statement there, it is a plus sign here. Probability of A plus probability of B. Make sense? Okay. So let's take a look at it like this. One card is randomly selected from a deck of cards. What's the probability of selecting a king or a queen? So first, probability of a king or a queen, rewrite it in as a formula. That would be my probability of a king plus probability of a queen. Okay, how many kings are in my deck? 4. So that's 4 out of, plus, how many queens? There we go. Out of, do the math. I said math, not meth. So that's going to be how many? What's 4 plus 4? 8. Out of 52. So let's go ahead, head it over to NumWorks. 8 divided by 52. As a simplified fraction, my answer is 12 over 13. As a percent, my answer is, say it loud and clear, 15.4. That 8's going to make that round up, right? Okay, so you have to know how to do both. What was it, 2 out of what? 213? Yep, 213, 15.4. Now, does that make sense? Is that pretty easy? Okay, I'm trying not to complicate anything yet. So, when we start the homework, only work on the problems that are saying that they're mutually exclusive. That's only the first couple of problems. The next set of problems are going to get a little bit more complicated, but I'm not going to do that before a weird 2-day lesson with 2 half days. So on Thursday, I'm going to come back and pick this one up, okay? So Thursday, we'll pick that one up. So other than that, Wednesday in class, we're going to work on the project, and you guys are going to work on getting your homework caught up. So make sure everyone likes, share, subscribe, hit that notification button, support my channel, right? Yeah. Buy stuff for the merch store.